Hello, today I want to talk about Kirchoffs' current law. So the main idea is that if they're so let me just quickly do it so I don't get talking at right at the same time. Basically, Kirchoffs' current law talks about how if current goes in, that amount has to go out. Let's say you can kind of say that all the values of current, they have to summarize into 0. So in the ways of let's say we have a circuit and the current is 5, it can't leave back. So basically over here you can say that's, so this is the positive and over here is the negative. So after kind of this point you can say that's like a negative, I guess. So that kind of well, how can I explain it? Basically in the way as if it balances it out. You can't give 5 and expect a magically 7 current to come out of nowhere. You're able to maybe do that with some circuits because of the diodes or that type of the engineering stuff. But logically, that with a normal diode, when you normal electricity, all that type of stuff, that's impossible because you can't get something from nowhere. So the reason they add up to 0 is on the example I just did. So you have a positive that flows, and then it becomes like a in a way they cancel each other out and becoming a 0. So here I have an example. So the junction is the area where the diode what's it called, in a parallel basically. So this part, right? So this is the junction, this is where the resistor is, another resistor here or whatever, it could be here, we don't know. But the main idea is that it's in parallel and that is current. Let's say we zoomed in, we just zoomed in, right? This is going on right here, right? So current flows, right? And 4 amps leave from because it goes towards the junction, it's a positive. So that means that if it goes to the opposite, the opposite is the opposite, so it's a negative. Going to the junction, positive, going out, negative. So the 4, it's kind of a negative. Now, what do you think is going to be I3? So let's imagine it's the last one, right? And take a guess, is it going to be positive or negative I3? So remember, if it I3, if it it's a positive, if it goes in means this, it would go like this, or it can be a negative and it will go out. Out is like this. Which one do you think it is? Well, let's find out. So I think it's very logical. I can explain it in basic words, but it's better to just see what's going to be happening so you understand better. We have I1 plus I2 plus I3. They're equal to 0 because of balance again. So we know the values of I1, 10. I2 is 4, so it's negative 4, don't forget, plus I3, and they all equal to 0. This equals to 6 plus I3. So 6 plus I3 equal to 0. So we can put the 6 over here, so the I equals to something. So I equals I3 equals to negative 6. So negative 6 is the answer. So we know that it goes like this, and we know that the value is 6 amps.
Negative 10 amps. So
however, you would you can just do this 6 and then think logically, okay, it's going out, blah blah blah. But guys, come on, engineering, you have to do this type of stuff for the marks. So I1, I2, and we need to find out I3. So again, they have to equal to 0. so 10 plus the minus 14 plus I3. These two give us negative 4 plus I3 equals 0. Like this, so I3 equals 4, which means it goes like this and a 4. Or you might be thinking, wait, how does it go left? Like, if it has to go like this to the resistor. Guys, circuits are a crazy thing. There can be like two batteries, they can be like this. Basically, it's not just, if you see a question like this, you can question the question. However, I think the exam boards, they're not dumb, so they know what questions they are giving. So yeah, so they have to equal to 0. Let's go. So we have a negative 8 plus 9 plus 7 plus I4. 1 8 plus I4, like this, equals 8 equals 0. So and then we do move it, negative 8, because it changes its power, whatever the value, I don't, yeah, and then negative 8, so this is negative 8. Okay, here's another example, harder. So we're given all these stuff, and we are given that I4 is 2, like, 2 times, basically, like, it's I, 2 I3s. So like, so 2 of them, right? So double the value of I3. And again, everything equals to 0. 12 is positive, is going in. Negative 8 going out. Then positive 20. All this equals to, so this is 12. So, wait, how can I do this? Let's just, okay, so 4. 24. 24 plus I3 plus I4 equals 0. Move that here. Oops. So 20. So these two equal negative 24. So we divide this by 3, because basically, you know how this is 2 of these, so there's basically 3 values, basically, like in the rabbit brackets. So we just divide by 3, so you see why. 24 divided by 3 equals 6 or 8. I need to check my math skills. And then to find I, like, that's what 1. So basically, we know that's a negative, by the way. So we know that this negative 8 amps, and then we double this value, negative 16, and we double it because so we know that it's 2 times this. So, and just to check the balance, let's check the balance. So how much is going out, how much is going in? So 1 is going in, this is going in, so 32 is going in. And then how much is going out? 16 plus 8 plus 8. Okay, 16 plus 16. And 32. And 32 is going out. This is basically a minus, so 0 is what it needs to be 0. So this is all right.